Welcome to Naveen Tech Hub.
Welcome to the AI Engineering Interview Guide for 2026. This video will cover key areas like generative AI, RAG, MLOps, and system design to help you master your next interview. The focus is shifting from traditional ML, which centered on single model training, to modern AI engineering. This modern approach emphasizes orchestrating foundation models and building production-ready systems using multi-agent workflows and retrieval pipelines. Stop tweaking prompts and start orchestrating systems. Let's review the causal decoder-only transformer architecture. Key modern components include SWIGLU activation for better performance and grouped query attention for optimizing memory bandwidth. Techniques like ROPE enable context windows of over 1 million tokens, pushing computational complexity toward ON. The end-to-end RAG architecture consists of an offline pipeline for building knowledge, including ingestion, chunking, embedding, and vector database storage. The online pipeline executes queries, involving query rewriting, retrieval using hybrid search, re-ranking to filter noise, and final generation. RAG evaluation uses the evaluation triad, focusing on faithfulness, context relevance, and answer relevance. Faithfulness ensures claims are supported by context. Context relevance measures if the right documents were found. Answer relevance checks if the final response addresses the user's question. Understanding the evolution of autonomy is crucial. Prompting is reactive and static. Workflows are predictable but deterministic. Agentic AI is proactive, using a dynamic reasoning loop for self-directed goal execution and tool usage, often with persistent memory. Agentic system design involves a continuous loop. Goal specification leads to reasoning, which triggers an action via a tool call. The observation processes the output, updates memory, and leads to iteration until the final answer. External tools like web search or database queries are essential for agents. Inference optimization focuses on three main areas: KV caching and page detention, reduce redundant computations, and memory fragmentation. Quantization compresses model weights for increased inference speed. Speculative decoding uses a draft model to achieve up to 3x speedup in token generation. The ML system design blueprint outlines 4 critical layers. Layer 1 handles user interfaces and APIs. Layer 2 manages orchestration and logic, including intent matching and guardrails. Layer 3 focuses on model serving and inference. Layer 4 covers data and infrastructure, such as vector databases. MLOps deployment strategies include canary deployment, rolling out the new model to a small subset for testing. Blue-green deployment maintains 2 environments for instant rollback. Multi-armed bandits is an online experimentation algorithm that dynamically maximizes performance metrics. Monitoring for model and data drift is essential. Data drift, or virtual drift, involves changes in input feature distribution. Concept drift, or real drift, means the model's fundamental understanding of the relationship between inputs and targets is wrong. Automated monitoring and retraining are the solution. Core ML fundamentals include the bias variance trade-off, where the goal is the optimal sweet spot minimizing total error. You must understand key evaluation metrics like precision, recall, and F1 score, and strategies for imbalanced data like SMOT and class weight adjustments. AI safety, guardrails, and ethics require a defense in-depth architecture. Layer 1 focuses on prompt and input guardrails against injections. Layer 2 ensures explainability and bias testing. Layer 3 involves output moderation and human-in-the-loop review for high-stakes decisions. Preparation is company-specific. For research companies like OpenAI, focus on core architecture and deep math. For hardware companies like NVIDIA, emphasize CUDA and inference optimization. For enterprise tech, master scale, distributed training, and agentic routing systems. The 2026 AI engineer must synthesize skills in software engineering, machine learning, and product sense. The final strategy checklist includes mastering RAG architecture, understanding agentic tool calling, reviewing inference optimization, and preparing system design trade-offs.